we continue by discussing pump installations and pumping principles. As we've mentioned, any pump is a device designed primarily to energize fluids so that they may be transported from one place to another. This procedure may form a vital part of a process operation. In a simple system, water is drawn from a river or a dam and pumped through a pipe, often up to a reasonable height above the pump level. The pump in this system, situated above the supply liquid, that is the dam, has to create suction in order to lift the water up to pump level. This is known as suction lift or static suction. After lifting the water, the pump then delivers it to a certain height above the level of the pump. This height we refer to as the static or delivery head, expressed in meters. The pump, when operating, is considered to have a total static head of its suction head plus its delivery head. Note that static lift is measured from the surface of the supply water to the shaft center of the pump. The static delivery head is measured from the pump center to the center of the discharge pipe. In practice, the head potential of any pump is affected by several factors, one of which is friction. Friction always occurs in a pumping system. Fluid particles rub against each other and against the pipe walls. Obviously, the smoother the pipe, the less the friction. Further friction, or resistance to flow, is encountered at every pipe bend and through every valve. Engineers have ways of calculating friction and desired flow rates, but this is outside the scope of this particular program. Other systems encountered involve the movement of liquid from a tank or vessel situated above pump level. Such an arrangement is known generally as suction head or flooded suction. In this way, incoming liquid is supplied to the pump under the force of gravity. The pump's lift capacity, or static lift potential, is greater in such systems. It is important that you know which system you are working in, because the diagnoses of faults or problems can often be traced to suction end situations. A pump working against a suction lift has to be primed before it will operate. Simply stated, priming means that the pump's casing plus the suction pipe must be full of liquid and free of air or gas. Most pumps have a priming plug situated above impeller level. The pump is filled to the level of the plug, and the suction side of the system is thus primed. Usually a foot valve or non-return valve prevents the fluid from running out of the suction pipe whilst the pump is stationary. A pump that is not primed will not deliver liquid, and prolonged operation under such conditions will cause extensive and expensive internal pump damage. After the break, we shall discuss important maintenance and operating procedures.